Okay, one of the questions that I got was help with domain and range for logarithmic and exponential functions. So this one we're going to focus on logarithmic functions, and I just want to remind you that all of your phones, your iPad and everything has an option to download the app Desmos. You can also go to www.desmos.com and it will help you to visualize some of these graphs. So I definitely encourage you to do that. The problem that we are looking at for this particular question is we have been asked to find the domain and the range of the function g of x equals -3 minus log base 3 of x. So in order to do that, we're always going to go back and look at the parent function. And the parent function of this is log base 3 of x. And that's what I have right here in blue, is the graph of log base 3 of x. And a couple things that I want to point out about this graph. So I want to point out this intercept right here. That is your x-intercept. Then I want to point out this point right here. Those 2 points, so we've got 1, 0, and then this point is 3, 1. That's going to help us to see the transformations of this particular graph. So this right here is called our parent function, and it is going to be transformed to help us get the -3 minus log 3 base 3 of x. 2 things are happening here. This -3 is our vertical movement, our up and down. Our up and down movement is always true to value. So that -3 means that this graph is going to move down. This negative means it's being reflected across the x-axis. So we're actually going to look at those 2 things separately, and then we'll see what it looks like for our final one. Let's talk about the domain and the range of this parent function. Domain is our x-axis, so we are looking at the x values that are associated with this graph. What is happening on my y-axis is this is an asymptote. This right here is an asymptote. And my blue line approaches 0, but it never, ever, ever touches 0. So the domain, which is my x-axis, or my x values, the domain never, ever, ever touches 0. So 0, our domain starts at 0, but 0 is not included, and that's why I have my parenthesis right there. And it goes all the way to infinity. And that asymptote is a key point in helping you to determine your domain for this. Now, for our range, our logarithmic function goes all the way down to -infinity. And you can see on the graph that the line is just continuing to go down, or the graph is continuing to go down. So we're starting at -infinity. Now, where our line starts to curve, or where our graph starts to curve, it still continues to go up. It's still moving up. There's no asymptote horizontally that's going to stop this. So the range for this parent function is -infinity to infinity. And so helping us to understand the domain and the range and where the asymptote is in relationship to the parent function is going to help us determine what the domain and the range is once we look at our transformed function. Okay? And so I want you to focus on this point 1, 0, and 3, 1. Both of those points are important for us to remember. Here, what I have here is I have part of the function, the -3 portion of the function. So I just want to show you that this part of the function is moving log base 3 of x down 3. So if we focus on this point right here, that is the point on my parent function. That point has moved down 3. So the negative makes it move down, and the 3 tells you how much that it moves down. Now, if you remember, if it was with the x, like if I had log base 3 of x and inside parentheses I had -3, that is right to left movement, okay? But when it's outside of the parentheses and it's away from the x, that's the up and down movement. So then, if you remember, on our original function, we had 3, 1. So what we have done is this point has moved down 3. We have no right to left movement because there's no value in the parentheses with that x, so we've just moved it down. So what this graph represents is the up and down movement from our parent function. Okay, now we're going to look at the reflection. So this is our parent function right here, our log base 3 of x. That's our parent function. The negative in front of the log means that we are doing a reflection across the x-axis. And if you notice, the reflection keeps that point at the x-axis. Our x-intercept stays the same. Now, what I want you to look at is this point that we had on our parent function, 3, 1. That point has become negative 3, 1. Okay? So when we did our reflection, the point 3, 1 on our parent function becomes 3, -1. And that's point 3, -1 is going to be very, very important when we put the reflection and the up and down movement together. Okay? So let's look at our movement here. So the blue graph is our original parent function. And so here is our intercept right there. And here is the point 3, 1. So what we've done is we've got 2 things happening here. The first thing that we've got to address is the reflection. So our point 3, 1, when we reflected it, we got this point right here. So if you remember, when we reflected it, we got our 3, 1 became 3, -1. Now, and this point stayed the same. So what is happening now is both of these points are moving down 3. And that's how we get our -3, our -3 movement. Okay? So, this graph, the green graph, is the graph of our transformed function. And our asymptote is actually the same. Our asymptote right here is x equals 0. And so, because of that, our line approaches 0, or our graph approaches 0, but we never ever touch 0. So that means our domain of our function that we're graphing, this is -3 minus log base 3 of x, our domain starts at 0, but 0 is not included and goes all the way to infinity. Our range, this time, our graph is, because we've reflected it, our graph is way up here, but it continues to come down and it continues to go this way. So we have our range from -infinity to infinity. Now, our asymptotes when we are dealing with logs. When we have logs, our asymptotes are, we have vertical asymptotes. When we're dealing with logs like this one, we have vertical asymptotes. And so you're going to be looking at something with my domain being limited. The opposite is going to be true when we're dealing with exponential. And that is what I'll be doing in the next video.